host.
Hi, my name is Ryan Benulo with SLA Software. And today I'm going to do a live demonstration of the SLA Software API management platform for the data.gov use case, an example of how to leverage our platform to manage public-facing APIs on the open internet. You might want to document your API, provide documentation to your developer community about how to use the API. You might be in the business of improving the security of your web service or API, interested in new emerging security standards such as OAuth and how to integrate OAuth with the identity provider of your choice, be it Active Directory, LDAP, or OpenID. We're going to focus on SOAP to REST protocol transformation and XML and JSON payload transformation, as well as the ability to attach SLA and quality of service policies for service level agreement compliance and license management of your APIs, as well as the ability to generate and view analytical reports and logs about how the API is being consumed over time. Ken Lane with the API Evangelist has recently published this Venn diagram that illustrates the technology, business, and political domains of managing an API. And we see there in the center of the intersection is where we've got some very important issues that are near and dear to most developers of APIs with regards to standardizing error codes across programming models, be it .NET or Java, where to store the source code and to iterate on source code as APIs evolve, such as code management systems such as GitHub were mentioned, creating consistent APIs so that developers can quickly access the API without having to read a lot of documentation about how the API was designed, as well as standardizing and enforcing security policies, things like rate limits and moving from basic authentication into OAuth. All of these are important issues to most developers, which we've got solutions for in the SLA software portfolio of products. We are completely REST and SOAP compliant. We've been in this business for over a decade. We've got the ability to generate Swagger documentation about APIs, help developers manage documentation, publish documentation about the APIs, create dashboards about how the APIs are being consumed, generate analytical reports, manage privacy policies and license agreements. All of this is areas that we'll get into in today's demonstration. To view the article that Ken published where this Venn diagram exists, visit the link at the bottom of the slide. From SLA Software's perspective, we've divided the API essentials into three categories. The community, where developers will discover APIs and where administrators of APIs will publish new APIs, where one can sign up for access to an API, as well as to collaborate with other developers about how the API was designed and should be used. The center category is the API gateway, where we've unified the processing of SOAP web services and RESTful APIs with the ability to attach security and threat prevention policies, to integrate across multiple target endpoints, to perform quality of service policy checkpoints, such as the number of transactions per second or minute that are authorized, the ability to normalize error codes and to handle faults with custom error message, and the ability to attach SLA policies and to enforce an SLA and to alert when conditions are violating SLA terms and conditions. The last category is the API Lifecycle, which is our Lifecycle Manager tool to manage the software development lifecycle process. For your SDLC team members, we'll collaborate to view the assets for each API and to visualize how APIs are being consumed across an organization, to visualize how a change will impact an organization prior to making that change. So the solution stack is visualized here. It looks like a community manager portal where one can look at analytical reports about the API's consumption over time, and a place again for developers to log on and to engage with other developers and the owner of an API. The gateway itself is where the API facades will be exposed to the public internet, protecting the actual target endpoint by only allowing authenticated and authorized connections to reach the target endpoint. And that gateway is where your integration will occur. And then finally, that Lifecycle Manager product to visualize your process over time. The logical deployment architecture of our cloud platform, which is also available to be deployed in your own data center if you don't wish to use the cloud, it looks like this. We typically have a tier of gateways in the edge of the network, which are illustrated here by this network director component, which is half of the unified gateway, the other half being the policy manager on the lower right-hand side, which is where key management, public key infrastructure is stored, where the OAuth provider is running, and as well as where we have integration to your own management operations consoles, as well as that community manager portal runs alongside policy manager, creating a web-based policy administration point for administrators to make changes to an API, as well as for a developer to access an API to start sending test messages to the API using a developer console. That database on the right-hand side is the database of your choice. If hosting it in your own environment, you have the choice of running Oracle, DB2, Microsoft SQL Server, or MySQL databases. The policy manager ships with a number of API policy configuration templates, which are declarative in nature. Now, in this OSGI JBI gateway, it's got the ability to enforce and execute these policies without the developer having to write any custom code whatsoever. The ability to configure these policies using a simple web-based user interface and a template approach is not only valuable from a time perspective, but it also reduces the complexity of things like security, which are hard enough. The fact that these security policy templates exist in the product out of the box is valuable to anyone just getting started in the business of securing an API, and that these security policies are world-class. Like I said, we've got integrated public key infrastructure. We've got the ability to do basic authentication, SAML authentication, OAuth, OpenID. A number of best practices here are implemented in our policy templates out of the box, as well as the ability for you to insert your own custom scripts for anything that we don't have policy templates for. You do have the ability to run your own custom JavaScript, Python, or Bean shell code on the gateway to enrich the policy templates per your own custom requirements. We've got a scalable API gateway. It's a horizontally scalable multi-data center environment where you typically have a Akamai tier or a global load balancer sitting in front of multiple gateways distributed across multiple data centers. Again, these gateways will perform the SSL termination and the authentication, authorization, and auto-logging of all the requests coming into your API. And that unified gateway is directly integrated with the API Community Manager portal, such that all changes that are made on the portal are immediately deployed and enforced by all the gateways that are creating proxy facades for each API managed in the portal. So lastly, the cloud solution architecture looks like this. You've got applications represented by the phone on the far left-hand side that are coming into a global traffic manager, which are then routed to the correct cloud endpoint that's closest to them, their closest regional node, where we've got clusters of Community Manager integrating with clusters of the unified gateway, which then run alongside clusters of the policy manager, which is used as the policy decision point. The gateway is effectively becoming the policy enforcement point, and as demand for resources increases, that cloud controller, which is our service mesh technology from our sister company Service Mesh, is used to spin up and spin down additional physical resources to increase the capacity and the performance of the system as demand increases over time. We also see we've got a disaster recovery cloud illustrated there on the right-hand side, where you've got data replication occurring between the databases and your ability to route a request to regional nodes as needed there by your CDN or your global traffic manager. Let's get into the demonstration. In today's demo, we'll illustrate what data.gov might look like had data.gov been built using our technology. In this case, we'll click on the sign-up process. If you wish to access this site, you can click on us-fed, us-fed.eap.soa.com. That URL on the top left-hand side there is a live URL If you wish to register for access to the site to become a developer to talk to these APIs, you can sign up using our registration form or log on with your Google account. I'm going to go ahead and log on with my own account. I'm already registered as a developer. And I'll start to demonstrate how to build a Department of Transportation statistics application that consumes multiple APIs. In this case, we've got one API connected to the application already, and my application is identified by this application ID, and I've got a shared secret. See here, I've got these two elements identify my application to our gateway hosted in the cloud so that the correct contracts and policies are enforced based on this application's identity. And we've got a developer console that we can use to start sending test messages to the API. Now we see that the security button's been activated, which lets us know that we've got to get a token in order to use this API. So when we click the security button, this is emulating the process that the client application will have to perform prior to sending a message to the API. In this case, we've got multiple grant types that are available for client applications to request: authorization code, client credentials, implicit and research center credentials. If we wish to supply the ID and the password in the same request as we ask for the token, we'll choose the two-legged research center credentials. If you wish to use a three-legged authorization code, you choose authorization code. And then upon getting a token, since this is integrated with Google OpenID, in this case, the get token link is going to check for a valid cookie that's authenticated with Google. If that cookie is valid, it'll then issue a token. So upon getting a token, we'll see here a pop-up screen. It went to Google real quick. You saw that link to accounts.google. That validated the cookie and that the password was still accurate and current. And then we see here that our OAuth server hosted in the SOA cloud has issued an access token and a refresh token and has linked that token to a scope of state resources and a policy type of OAuth, which is being used to authenticate this client application. So we've now linked my user account to the application identity, and we're going to send a request for statistics from the JFK airport in the year 2011 from the month of December, airport code JFK. And upon running this, we'll get data back for what's occurred at the JFK airport in terms of the number of employments and deplayments at that airport. If we wish to change the airport to, for example, the Atlanta airport, we'll see that those numbers are now Atlanta airport specific. If we don't want our data back as XML, but are building a client application that renders or parses our data out using JSON format, then the gateway will transform the payload from XML to JSON simply by checking that accept header. And upon seeing that we've got a request for JSON, the gateway then transforms this XML data into JSON for the user. And the owner of the API had no work to do in order to have this transformation take place. That entire transformation was performed on the gateway without the target endpoint even knowing that occurred. That's a good demonstration about how to use the Community Manager portal to start sending test messages to an API prior to having a client application. Now let's walk through the process to attach a second API to this application. In this case, we've got one API connected. We'll search for the FAA API using our search window here at the top. Upon finding the API we think we want to access, we'll read a little bit of documentation to ensure this is indeed the API we wish to use. Looks like it's pretty simple. It requires one parameter, airport code, for a get operation. And we can click on the raw link here and look at the Swagger JSON representation about this API, which is a nice valuable feature of the Community Manager portal in that it generates this Swagger automatically. And then this is valuable to developers that wish to compare versions of the API. If the FAA releases version 2, which may have additional operations, by doing a diff on the Swagger, you can quickly identify how the API has changed from having one operation that uses airport code in the beginning to having additional operations that would quickly be visible to anyone that compares the Swagger without having to read a whole lot of documentation manually. So this looks like a good API. In order to access the API, we will walk through the wizard here. to connect the API to our app using the Access wizard there at the top right. Upon clicking that, we'll choose the application we wish to connect it to, our statistics app. Select the environment we're connecting to. If Sandbox was available, you'd see a Sandbox link there. The last step, or the third step in the process, is to connect a quality of service policy to the application. So for demonstration purposes, I'll just connect the Sandbox free policy, which is 10 transactions per minute, I happen to know. And then we'll look at the legal agreement, have to read it and accept it before the contract is complete. Saving it is now going to put this application or this API in an access pending state. And that's going to require me to log on as an administrator now and to approve this request. Upon logging on as administrator, that dashboard that we're showing here is going to have this notification. We've got a new application connecting to an API that requires approval. So we'll click the approve button there and approve that request. And then upon approving the request, we will activate the contract with this activate button. And now the contract is active and this API is ready to use. If we wish to, since we're logged on as administrator now, modify any of the policies that are attached to this API, we'll switch over to our Policy Manager tool and just log on. Wrong password. There we go. Upon logging on to Policy Manager, we can review policies that are attached and make changes to policies that are attached by going to the Policy section, where we'll see the policies that are in the system that are available to be connected to APIs. The operational policies are attached at an API level, and the quality of service policies are attached at an application level. So we just attached the Sandbox SLA policy to this API, and if we wish to modify that Sandbox policy, it's a very simple to use, like I said, a declarative template to make changes to these policies, no code required. And if we wish to reduce that from 10 transactions per minute to 5 transactions per minute, we just modify that throughput to 5, change the default message there to 5 transactions per minute, and then click Finish. And now that new policy is in effect, and it's immediately going to be enforced by the gateway. So we'll just switch back over to the Community Manager portal, and we will log out and log back on as a developer. And now, after logging on as developer, we will go into the application we're building, and we'll see that we've got 2 APIs connected at this point. If we look at their status, we'll see that they are now both activated. And if we go to the developer console, we can now send messages to the second API we connected, which is the FAA API. Upon connecting to that, we'll see that again we have to get a valid token. So we'll get a token. Upon receiving a token, we can now send some test messages to this endpoint. This requires, again, one parameter, the airport code. Upon clicking Run It, that'll send the message to the target endpoint after validating the bearer token here, which we just attached. And we'll see our data coming back in XML format. Looks like the current conditions at JFK are partly cloudy, and there are no delays at this airport. Again, we can transform that payload from XML to JSON using the accept header there. Run it again. We'll see that, again, our data is transformed by the gateway. And let's just check to see that that quality of service policy is taking effect. We'll run this a few more times, and we should effectively get a policy violation on the 6th request. There it is with our JSON response code that our quota has been exceeded. and it's set for 5 transactions per minute and to try again later. So we're now seeing quality service policies being enforced after OAuth authentication has been occurred, and that policy is, again, specific to this one application, which is identified by its application ID, which is visible here for that developer on the details page of his application. Now, a record of all these transactions has been logged in the database, and we can view the charts for these transactions in the production environment by selecting that production radio button. And we'll see here a record of what's just occurred in the past 1 hour. All the transactions have been sent to this. The green bar illustrates successes. The red dot illustrates the failure. That failure is likely that quota policy being violated. If we click on the logs link, we'll see the detailed logs for this environment. And if we wish to find out why this fault occurred, we can then just click on the link for that record, scroll down to the response message, and we'll see the reason for the fault was indeed the quota was violated and they've exceeded their terms and conditions of their contract. So we've got integrated monitoring and analytics alongside a developer console, which gives the developer a lot of data on both his headers that are being sent by this developer console so that the client application can emulate the type of request that is being made by the developer console. Again, the developer console is there to teach developer how to code his client application and how to send requests properly to the API. And again, we also illustrate what the response message will look like coming back in JSON format or XML format so that the developer knows how to parse that data correctly and render it in the user interface. As a developer, one might also wish to collaborate with the owner of the API to give feedback on how the API is performing. For example, on the discussion board, we could open up a ticket and say, please increase my SLA. We can open up a minor ticket in the production environment for the FAA API. We can talk about the SLA quota and say, please increase SLA for quota from 5 transactions per minute to 50. And submit that to the owner of the API. We've got an open ticket at this point. And if we log out and log back on as the administrator, that administrator will see that ticket and then can take action on it. And here's our ticket that was opened up. We can edit the priority of this ticket. We'll say it's major. All right, so we've got the administrator making a note that we'll make a change to that sandbox policy today. And again, to make that change, we go back over into Policy Manager. We'll open up the policy that requires change. And at this point, we will increase that to 50 as requested. This is taking just seconds to do. At this point, that change has been made. We can log out, go back over here to our ticket, resolve this ticket. And now the ticket is closed. Log back off, log on as the developer. The developer should see a notification that the ticket has been acted on. There it is. The change has been made. The developer sees that change and can now start sending some more messages to his client using the developer console. That target was the FAA API. Get our token. After getting the token, fill out the form with the airport code. I'll pick a different airport. Go to the Atlanta airport this time. Run it. We'll see now that we can send way more than 5 transactions per minute since it was set to 50. No quota policy violations. I've sent now about 10 requests, going on 15, and we're in business. And I'm not going to send 50 requests. I think we get the value of the system from the both parties' point of view. The owner of the API's point of view is being managed here by the developer of, or by the administrator of this portal. The owner of the API that wrote the API didn't have to make any code changes to the API for these policy changes to take effect. And we also have integrated monitoring and reporting about the API with no involvement of the developer of the API whatsoever. All of those monitoring reports were generated by our system automatically with no custom code required at all. Hopefully that demonstrates the value of the system. If you wish to obtain your own tenant in the system, you can do so by going to open.sla.com and requesting a tenant in our cloud environment of your own by clicking the Add Tenant here, sign up as a tenant button, and that'll begin the process to become a member of our integration platform as a service. Again, we look forward to doing business with you, and if you have any requests or questions, you can send me an email, find me on Twitter, or send an email to our sales organization at sales@sla.com. Thank you for your time.